Hey everyone, for today's problem, we're going to look at some scheduling problem. It's in logical and reasoning section. And to start things off, just go through the question, read all the 4 clues given here, and then we can begin. There are 5 boxes, T, W, T, U, W, X, and Z, which have to be delivered on consecutive days, Monday, Tuesday, Wednesday, Thursday, and Friday. We'll just draw our table. This helps us solve the problem much easier. And these are the 4 conditions, but I've written them in a slightly different way. Box X can never be Monday. If box T is delivered on Monday, then box X must be delivered on Friday. If box X is delivered on Tuesday, then box U must be delivered on Monday. Z and W are always next to each other. Z and W are always next to each other. Not just next to each other, they have to be delivered on the following day. If Z is delivered on Monday, we have to deliver W on Tuesday and so on. For example, if Friday is when we deliver Z, then it has to be delivered on Saturday. But in this case, we don't really have Saturday, so Z can never be delivered on Friday. Hope that makes sense. Let's just try to proceed with question number 1 and try to solve it. Box W could be delivered on any day except. So to solve these types of questions, just put W everywhere, right? We have 5 cases. So we have to verify whether this is valid or not, and so on. All the 5 cases. Right now, we can look at condition number 1. It's talking about box X, but we're not really dealing with box X right now. And number 2 is talking about T, number 3 is talking about X again. So we're not really dealing with number 1, clue number 1, 2, and 3 right now. But if we look at clue number 4, it tells us that Z and W has to be on consecutive days. So it means that whenever you deliver W, the day behind it, we have to deliver Z. So in every case, we can just put Z behind. And in this case, we can see that Z has to be delivered on Sunday in order to meet this condition number 4. So that's not really possible, which means that we can't deliver W. We can't deliver W on Monday. However, we can deliver it on Tuesday, we can deliver it on Wednesday, Thursday, as well as Friday. And if we look at the other conditions, talking about T, U, and X, we're not really dealing with any of those variables right now. So this is the end of problem number 1. And we've solved it. The answer is Monday. Could be delivered on any day except Monday. Okay, let's clear the board and we'll try to solve problem number 2. Problem number 2 says that if U is delivered on the day after box T, so after T is delivered, U has to be delivered. Okay, and this condition, we can just call it number 5 for now. Okay, this only applies to question number 2. Okay, when we start going to number 3 and number 4, we have to forget about this condition. All right, we have a new condition. The question says, which of the following is a complete and accurate list of the days on which box X could be delivered? Great. So let's make our table. That will help us solve this problem easily. Monday, Tuesday, Wednesday, Thursday, and Friday. So we have 5 possibilities. X can be here, or here, 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 or here. If we look at clue number 1, box X never on Monday, we can directly eliminate this one. So Monday is not an option. Okay, so I'll just do this. Monday is not an option. Tuesday. Let's look at Tuesday. Is there any condition that talks about X on Tuesday? Yes, there is. If X is Tuesday, then U equals Monday. U equals Monday. We have a condition here which says that U is delivered the day after the box T is delivered. It means that T has to be right behind U. In this case, T has to be delivered on Sunday, but there is no Sunday, and we can't put T in Sunday anymore. Neither can we put it on Friday, because Friday and Monday are not consecutive days. It means that Tuesday is also not a viable option. So let's check the other three. If X is on Wednesday, there's nothing about X on Wednesday over here, so we can just plug in our other letters. For example, TU and ZW, right? So this is valid. We can deliver X on Wednesday. Moving forward, X on Thursday. Is there anything that talks about X on Thursday? Well, not really. So let's just try to plug in our other letters, TU and ZW. So TU and Z. Oh, oops. We have run into a problem. We can put TU, okay, here, or maybe here, or yeah, there are two legal positions. But if we put TU, we can't put ZW, and if we put ZW, we can't put TU. It means that if this condition were to be true, condition number 5, then we won't be able to place X on Thursday. We won't be able to deliver X on Thursday. It means that so far Wednesday is the only correct option. Let's look at number 5, which is X on Friday. There's nothing really about X on Friday. So U, T, and ZW. It's possible. You can swap things out too. ZW and UT. Sorry, TU. TU. We are able to satisfy all the conditions. Meaning we can deliver X on a Friday. So the answer becomes Wednesday and Friday. Option number D. Let's start with question number 3. If box W is delivered on Wednesday, which of the following could be true? Let's draw our table. Let's make it a little pretty this time. Yeah, it's not very pretty, but we'll work with it. So it says that Wednesday, W equals Wednesday. Our W is fixed. And if W is fixed, our condition number 4, ZW is always fixed. Now, using these conditions, we have to find out whether we can fulfill the rest of the conditions, plus these new conditions. So number A says, box U is delivered on Friday. Box U is delivered on Friday. We don't really have to look at anything anymore regarding U, because there's no rule for U. Box X can never be Monday, right? So box X has to be here. And then we can put box T. But it also says that if T equals Monday, then X has to be Friday. And X has to be Friday. And we can't put X in Friday. And neither can we put X on Monday's position as well. Which means that U being on Friday is not possible. Not possible. We can move on to number B. Number B says that box X is delivered on a Tuesday. We can clearly see that it's not possible because there is no room for Tuesday. It's already occupied by Z. So this is not possible again. I'll just write it down here that A condition, B condition. Let's look at C now. Box X is delivered before box T. Well, we can't put X here anymore in Monday's position, but we can put it here, and T can come after that. There's no rule for T anywhere. It means that here we can put U. And looking at all these conditions, I think we don't have anything to worry about. So number C is definitely possible. Number C is definitely possible. Let's look at the last and final one, which is number D. Box X is delivered before box U. We can't put X here, and we can try putting box X here, but we'll have to put U here. And if you remember, X and U together means putting T here, and we can't really have this situation, because if T is Monday, then X has to be Friday. X has to be Friday. So we can't really say that this is possible as well. U, and then putting X here, X coming before U, right? X delivered before U. Yeah, it's not possible. So we'll mark it down as not possible. Number D. And finally, let's look at problem number 4. Let me mark the answer, which is number C. So C is possible, everything else is not possible. I'll clear the board and we'll do number 4. Number 4 says, if the box U is delivered on Monday, U is delivered on Monday. Oh, sorry. U is delivered on Wednesday. Which of the following must be true? Let's create our table again. And using the table, we'll be able to solve this much easier. I won't make it pretty this time. I'll just draw the lines by hand. So let's fix the position of U. U will be here. Okay, we don't really know how many cases there are going to be, but we'll make 4 for now. Looking at this 4, there's not a lot of hard conditions for U. So let's try to put our hard conditions first, which is ZW. So ZW can be here, or ZW can be here. These are the only 2 possible conditions. If I were to put X here, it would violate rule number 1. So let me put X on Tuesday. If X is on Tuesday, then U equals Monday. So this is not possible. I can't put X on Tuesday. It's not possible. Neither can I put X here. So this whole condition just collapses. Question number A says, box W is delivered before box T. So let's come back to this. Let's try to put the value of W somewhere. Okay, so these are the only 2 possible positions for W. We can't put it on Monday, we can't put it on Thursday, for obvious reasons. Now let's try to put the value of T somewhere. We can't put X here or here. Let's look at the first one. Maybe we can put T here and X here. So this is possible. box W is delivered before T. So number A is actually possible. Okay, we're gonna erase this as well as these things. I think our entire problem, A to B to C to 4, C to D, can be solved using this diagram. Box T is delivered before box X. So let's try to put T somewhere. Maybe we can put it here and X can be here. So T is delivered before box X. Is there any condition here that we have to be worried about? Not really. So number B is also possible. Number C, box T is delivered before box U. So T is delivered before box U. This is not possible. Box T, okay, if we put T here, then we have to put X here, which is not possible. So if we put T here, we have to put X here, which is also not possible because X can't be Monday. And if we put X on Tuesday, it means that U has to be Monday, which is also not possible. So number C is not possible. Let's look at number D. Box X is delivered before box W. In this first case, it's a definite no. In this one, it's possible, but if we put X here, it violates rule number 1. If we put X over here, then U has to be on Monday, which is also not possible. So for that reason, C is also not possible. Let's verify number A and number B again. Box W is delivered before box T. Box W is delivered before box T. Okay, we can put T here or here, and we can put X or here or here. It doesn't really matter. As for number 2, box T is delivered before box X. So we have to put T here and then X here. Looking at this condition, if T equals Monday, then X equals Friday. We shouldn't really be concerned with this one because it's talking about T first, right? So if we were to put T here first, then maybe we'd have to be worried about putting X on Friday. But right now, we're putting X first here, and then we're putting T. And here it says box T is delivered before box X. Okay, so these two, number A and number B, are possible. We've verified it once more, but just to be sure, I'll double check. We are looking at question number A. No, question number B. So I may have made a mistake somewhere because we are right about number A, but we're wrong about number B. Let's see where our logical flaw was. If T equals Monday, X must be on Friday. Friday is already occupied by W. Friday is already occupied by W. Okay. We're not really concerned with that one. Okay. So this condition, the one that was below, doesn't really exist, can never exist. It has to be this. Okay, after looking at this problem, it seems that this condition, box T is delivered before box X, cannot be true because we're gonna have to put X on Friday, and putting X on Friday means we have to put T on Monday, which is not possible. So only number A is the correct answer. A little bit confusing, but as we solve more and more problems in this category, it will start getting easier. See you in the next video.